All right, so now we're gonna kind of talk a little bit more in depth about what makes up this concept of charge. So in the last section, we talked about positive and negative charges, and we're going to take a look at the atomic structure that actually is causing that, and we'll take a brief look at molecules. So this is kind of a little bit of a chemistry little section on what's causing this charge. So in any anything is made up, of course, by atoms. So atoms, that's why you can't trust them, right? They make up everything. So with an atom, it has a dense, positively charged nucleus, and then there are electrons orbiting around. And you learned all about this in chemistry, but the Bohr model of the hydrogen atom, we have electrons all floating around the nucleus and surrounded by electrons. And of course, also in the nucleus, you also have neutrons. So the nucleus is very, very dense, positive charge, and then there's an electron cloud. All these electrons are orbiting around the nucleus. So charge, like mass, is a property of electrons and protons. So it's a property of what's actually making it up. It's a balance of positive and negative charges. So electrons and protons are the basic charges for matter. There are no other sources of charges. If it's positive charge, there's more protons than electrons. If it's negatively charged, there's more electrons than protons. So if it has an unequal number of charges or unequal number of protons and electrons, then it is charged. So most large-scale objects or macroscopic objects have an equal number of protons and electrons so that they are neutral. So we call that being electrically neutral. Now, when we're charging something, objects can gain a positive charge not by gaining protons. Protons don't move. Protons are the dense nucleus. So if an object is getting positively charged, it's not gaining protons, it's losing electrons, or it's giving off electrons. Protons they're extremely tightly bounded within the nucleus, but electrons are in the electron cloud, so it's much easier to strip them off of the atom and transfer them. So in chemistry, you talk about this a lot. We'll talk about this briefly, but we can ionize a atom and the process of ionization is the process of removing electrons from the electron cloud. So if we have a positive charge on the left here, that means one of the electrons that was in the cloud has been removed from that atom. A negative ion is when an electron is added into it. So this one maybe right here, it wasn't there before, but due to charging, it gained an electron. Now that gets into all sorts of chemistry implications like bonding, so covalent bonding, ionic bonding, right? All of those things have to deal with ionization of atoms. So if we are missing an electron, it's a positive ion because it has an extra positive charge compared to the number of negative charges. But if they accumulate that extra electron, or if they accumulate extra electrons, they become negatively charged and negative ions. If we look at what's going on at the molecular level, we can create these ions when we break these bonds and transfer some of those molecules. So the bonds are, if we're charging by rubbing something, it's charging by friction, and we break those bonds, and we can strip atoms then of their of their negative charge. Now in physics, we use charge is represented by the symbol Q, and the unit is a coulomb. The fundamental charge of one electron, this was determined by Millikan's oil drop experiment, is the charge of one electron or one proton, and it's 1.6 times 10 to the negative 19th coulombs. So if I have multiple, let's say I have 2 extra electrons, my overall net charge would be 2 times the charge of 1 electron. Looking at what actually make up the atoms, we have protons, neutrons, and electrons. Protons and neutrons have roughly the same mass, and protons have a charge that is the equal but opposite to an electron. Electrons are very, very, very small, about a thousandth of the mass of a proton. And that's like why in chemistry, when you talk about molecular mass, it's the mass of the protons and the neutrons, and we ignore the mass of an electron because it's so small relative to the rest of the molecule or the atom. When we talk about insulators and conductors, which we talked about in the last section, the electrons of an insulator are very tightly bound to the positive nuclei and they don't move around. So if we charge an insulator, we have to leave a patch of positive or negative charges, but the patches themselves are not actually moving. They're not mobile. With conductors, you probably learn about the electron cloud, or as they're sharing electrons, it's much more fluid. So there's more valence electrons that are easily movable or shareable between different objects. So they're very weakly bounded. Often we talk about a sea of electrons when we're talking about conductors or metals, and those can easily be detached from their parent nuclei or from whatever they're supposed to be bounded to, and they can easily be shared. So if we have a ton of positive and negative charges, or negative charges kind of floating around, that is what we call a sea of electrons. In physics 2, we get more into this quite a bit, but we can also create dipoles, and we don't really need to worry about it for this year, but that's where we still have that positive nucleus and our negative electrons floating around that nucleus, but due to some type of external charge, those electrons tend to float towards that external charge. So when we talk about this will be testing my chemistry knowledge a little bit, but when we talk about something like water, right? Water is H2O, so it's 2 hydrogens and 1 oxygen. So the oxygen bonds with the hydrogen, and when you talk about like the structures of it, this is the dot structure, right? So I have these dots represent the electrons. And again, if you haven't taken chemistry or if you're not remembering all this, that's okay. But this creates a net negative side, and then the hydrogens are our net positive sides. And there's a separation between that negative and positive, and that is creating this electric dipole. So water itself is a dipole. When there's this polarization, there's this external force, and that causes those different bond angles with the Lewis dot structures, and that's because of this external force that's causing this attraction between these two, between the atom on the right and just the positive charge on the left. So there's a net force that's exerted towards that positive charge. Here's water again. So this is an example of hydrogen bonding. This is what I was just talking about. The electrons are shared between hydrogen and oxygen, and that leaves this net negative charge. So what we have here is we have a positive right-hand side and a positive left-hand side and a negative right-hand side. So there is this bonding, but it also creates this electric dipole. So a hydrogen bond is the weak bond of hydrogen from one molecule of an atom and the negative oxygen atom in the other molecule. These weak bonds give water its kind of stickiness, which is responsible for its unique properties like expansion and freezing when it changes temperatures, and how it changes size as well. So hydrogen bonds are extremely important in biological systems. We're not going to get into them in physics 1. In chemistry and in physics 2 a little bit, we get into like concepts like nucleotides, and in biology you can talk about DNA, the helix structure, right? There's so many implications and applications of this, but they're not covered in the scope and sequence of this class. So here's an example of a DNA molecule, and there's this constant hydrogen bonds that join your guanine and cytosine, and then there's hydrogen bonds that join thymine and I forget how to pronounce it, adenine, whatever. I'm not a biology teacher, sorry. But these are caused by hydrogen bonds, and that's why they uniquely bond with each other, and not, you don't see a thymine and guanine, right? You just get Ga or you get G, C, and Ta. So that's due to those hydrogen bonds. But again, that's not covered in the scope and sequence of this class. We just care more about that positive and negative charge concept. And since we understand that positive and negative charge concept and that law of attraction and repulsion, if it's two positive charges, two negative charges, or a positive and a negative charge, we can determine the magnitude of that force that attracts or repulses them, because that's what we care more about in physics, right? A lot more study of forces. And we'll be taking a look at Coulomb's law then in the next section.